Hi, this video I'm going to particularly look at steam table, and maybe later on we're going to look at also the R134, the refrigerant table. So at the back of your thermodynamics textbook, there are two appendix. Appendix 1 is property table and charts in SI unit, and the property appendix 2, I just changed to, let's see, it's English units. And however, the table of contents for each one of them, it's the same. For example, table, let's see, table 3, table 4, table A4 is saturated water temperature table. And if you go back to the appendix 1 SI unit, it's also saturated water temperature table. So it's the same contents, it's just in a different unit. Okay. So knowing that, I'm going to particularly look at those few tables. That's going to be our table A4, 5, 6, and 7. Okay, A4, 5, 6, 7. And the A4 is saturated water temperature table. Table A5 is also saturated water, but it's pressure table. And table A6 is superheated. Table A7 is compressed liquid. Now let's look at one. Let's go to table A4, for example. All right, I'm at table A4. And those are the tables you're going to use quite a bit in thermodynamics. From today on, you're going to use those appendix every day. Pretty much every single problem, you're going to come back to figure out which table to go to and where to get the information. So it's kind of like a dictionary, and even nowadays we don't use dictionary, but you are using this thermodynamics table to solve your problem. This is like absolutely necessary tool. All right, table A4, it's temperature table. What that means is if you were given the temperature, the first column is the temperature, and you can find a few things because it's a saturated water. You can find out what's the saturated pressure. For example, at 100 degrees Celsius, we know that's water boiling, right? So at the time, we know water boil 100, it's at our atmosphere pressure. Our atmosphere pressure, it is 101.42 kilopascal, okay? Then also, you can figure out specific volume at that particular temperature. What's going to be the VF? VF is very small because that's the specific volume for saturated liquid. Okay, that's how many meter cube per kilogram. However, for saturated gas, VG is greater. It's 1.67. All right, then we continue. Then this is going to be internal energy, and that is going to be UF. And this column is UG, and we know UFG is the difference between UG minus UF. Feel free to go ahead and use your calculator to verify using a couple of the scenario, UG minus UF, see if you indeed get this UFG column. Then you have this enthalpy, same wise you have HF and HG, that indicates the specific enthalpy at saturated liquid. And the HFG is the difference between HG and HF. And this is entropy, so you give an SF and SG. Okay, so move on to table A5. Table A5, it's also water table, and however this one is pressure, which means you're given the pressure, you can find the rest. So again, using the pressure we normally know, which is 101.325, that's our atmosphere pressure. And guess what's the corresponding saturated temperature? 99.97, round up to be 100 degrees Celsius, right? And then you can go ahead and find VF and VG, etc., UF, UG, okay? Now, continue. Then we have table A6. At table A6, we land down to superheated vapor. Superheated vapor, we have several milli-tables. Milli-tables are classified by pressure. At different pressure, be aware, this is in megapascal. Mega is 1000 kilopascal, or mega is 10 to the power of 6 pascal. And in the parenthesis here is very helpful. That is the saturated temperature, which means boiling temperature at that particular pressure. Okay, so at 0.01 megapascal, which is how many kilopascal? 10. That's right, 10 kilopascal. At 10 kilopascal, that's the saturated temperature. If you want to go back to verify it, you need to go to table A6, A5 at 10 kilopascal. So we're at 10 kilopascal, and that's our saturated temperature, 45.81. So remember that number? 45.81. And that is exactly that number inside the parenthesis. That's the saturated temperature. And so, in that situation, all those temperatures have to be what? Above that number. So they can be considered as superheated vapor. So if it is above this number here, we have superheated vapor. And then we'll have their corresponding V, specific volume, and U and H and S at that particular temperature. Look across, right? So those many tables help us figure out the pressure, and the temperature help you figure out the rest. Then we're gonna looking at A7. Table A7 is gonna be compressed liquid water. Those are the water that have less than the saturated temperature. Again, you have many tables. At 5 megapascal, this is gonna be the saturated temperature, right? So when you have a temperature less than that, that's gonna be the compressed liquid. So they give us the other property like a specific volume, V, U, H, and S, etc. And you be aware what is the lowest pressure they have over here. They have many tables for pressure. The lowest pressure they have here is 5 megapascal. Okay, so here is just give you a little time to make a mental note. When you have compressed liquid, when you have a pressure that is less than 5 megapascal, this table cannot do any good anymore, right? But that situation occurs. Sometimes when you have compressed liquid that has its pressure is less than 5 megapascal, what can we do? That's something for you just to have a mental note. We'll come up with the answer in the next couple of videos, but that's it. So that's gonna be the steam table. Again, table A4, A5, A6, A7. Table A4 and A5, it's basically the same. They are all saturated water, except this is if you have temperature. If you were given temperature, you go ahead and use A4. If you were given pressure, you use A5, right? And A6 is superheated water, and A7 is compressed liquid. And if I were going back to Appendix 2, which is in English unit, it is the same thing. A4, A5, A6, A7, you notice it's the same group. But now let's just go look at one table only. I just want to point out the difference between metric versus English. We have English unit, you're going to have like E after that. For example, table A4E, that's the English unit. And you look at this here, temperature is in Fahrenheit, no longer degrees Celsius. Pressure is not in Pascal, it's in PSI, pound per square inch. When you have A here, that means just absolute pressure, right? It's not gauge pressure or vacuum pressure. Now you have specific volume. Instead of meter cube per kilogram, you have cubic feet per pound mass. Internal energy, instead of kilojoule per kilogram, you are given British thermal unit, BTU, over pound mass. Same thing for enthalpy, BTU per pound mass. So enthalpy is energy unit as well, okay? Entropy, then you have BTU per pound mass, then per R, R is ranking, okay, divided by the temperature. So that's the difference. All right, hopefully you have a better grasp of those tables. There's 4 sets of table, and that's our steam table, which is our water table. All right, I'll see you next time. Bye.